All right, so two things we're going to be talking about today is the mean value theorem. This is for derivatives, first 2 pages, and then the mean value theorem for integrals, the next 2 pages, okay? Now, not tough stuff. Okay, now the mean value theorem, these are always really wordy. So I will say it and then I will try and, okay? It states that there's a point C on a continuous function f with the closed interval ab, and f of x must be differential on the open interval ab, where the tangent line to the function of point C is parallel to the line passing through a f of a, b f of b. Now, all this is saying, given that these 2 points, okay, a and b, I find the slope. It says that there will be at least another place on that entire graph that will have the same slope as it. Okay, and if you really think about it, that has to happen, right? Now, when you find the slope between here and here, for those physics people, like if this was a distance time graph, right? That would be average velocity, right? And that point there is instantaneous velocity, right? If you just find the slope at a point, that's instantaneous. Now, if you've got an average velocity, it kind of makes sense that at some time your instantaneous velocity was your average velocity at one point. Okay? It may be at 5 different points, but at least at one point. Okay? So let's kind of just write that down. So this means at some value of c, okay, and c we're going to call like instantaneous. Velocity. If this was a distance time graph, it will equal the average velocity of 2 points on the function. Okay, so they just may ask on the AP exam, find the mean value, or find the point that has, well, you'll see how the questions are asked. But anyway, yes, it's first of all, how do you find the slope of here and here? F of b minus f of a over b minus a. Rise over run. The y's over the x's, right? Now that gives you the slope of this. Now, if you know the slope, and you know how to find the derivative of the function, to find a place that has the same slope, make your derivative equal the slope and solve for the x. Okay? So I'll show you what I mean. So basically, the derivative of c, right? If you put c in the derivative, we want to find out, hey, when do you get the same slope as those 2 points? That's all it is. Okay, so let's see how this works. The value of c that satisfies the mean value theorem, that's how it'll be asked on the exam. Okay? So if we didn't go through the mean value theorem, you'd probably be skipping this one. So the value of c that satisfies the mean valuable theorem on interval 0, 5 for the function x cubed minus 6x is. Okay, well, first of all, let's find the slope between 0, 5, right? So it's f at b minus f at a. So that would be 5 cubed minus 6 times 5 minus 0 cubed minus 6 times 0 all over 5 minus 0. This will give you 95 over 5, which equals 19. That is the slope of A and B. Okay, the two x values A and B. Now, I just want to kind of show you, since this is notes, right? So visually, this is what, say, the function looks like. And from 0 to 5, so say here is 5, that's 0. So this is 5, and that's 0. We found that the slope is 19. Does that make sense? Okay? Because that's the hard part. So I find my slope, and it says, hey, find me another point on this graph that has that same slope. Find me a tangent. Right, so if I do, so f, the derivative at c, would be 3x squared minus 6. So if I want to find an x that has the same slope, I'll just go 19 equals 3x squared minus 6. Okay, we'll add 6 to both sides. I get 25 equals 3x squared. 25 over 3 equals x squared. And when you take the derivative, when you take the square root, you will go plus or minus 25 over 3 equals x. Or plus or minus 5 over root 3 equals x. Now, so there are two places, but it says on this interval right here that we're just going to be doing plus 5 over root 3 equals x. This actually, sorry, this is bad. Why did I do that? For all of these, because I'm actually finding a c, we're going to change it to that variable. That should be c all the way down. I swear when I rush, it takes them twice as long. Okay, so what is 5 over root 3? Can someone just kind of put it in their calculator? I put it in and I forgot to write it down. Can anyone put that in? 2.886. Okay, so that's approximately 2.886 that we got, dot. So, and I didn't draw my graph very well, because it should be more like that. But you could see at this point right here, the tangent would have the same. So find your slope of your 2 points. Make your derivative equal the slope and solve for c. This would be c right here, which is plus root 5 over 3. Oops. Plus 5 over root 3. Now the other one would have been this one here. But it wasn't in our interval. But the mean value theorem is, if I give you 2 points, find me a tangent that would have, or the c that would have a tangent at the same. Okay? So, and then I've given you 3 other questions to try. But even this one is a kind of a good question. Use the graph of f to estimate values at c that satisfy the conclusion of the mean value theory. That's what it's called, the conclusion of the mean value theory, from 0 to 8. Now this is 8, and that's 0. So if we draw a line from 0 to 8, okay. So it says find any tangents that would have the same slope. and it says estimate, like what it would be. So I'm seeing like this, that spot there. I'm seeing that there, this here, and that one there. That's all the mean value theorem is. Okay, and then, like I said, I will post up all the solutions for the other two. And the answers to this is like, okay, so it's like 0.8 would be one, that would be a C, right? This one would be like 3.2. This one would be like 4.4. This is like 6.1. So all the C's would equal 0.8, 3.2, 4.4, 6.1. This was on an AP exam. Okay, it's just an estimate. Yeah, but they will have those numbers as a multiple choice, right? So it's not like, no. And you know what, it's not a bad written, right? They're going to look at it. They're not going to be like, ooh, 0.8. Yeah, they're really good about it, okay? They're just seeing, do you even know what it is, okay? Does that make sense? This makes sense? Again, not hard, but kind of impossible if you haven't seen it. Now the integral one. Okay. Sort of. They're quite different actually, considering they have similar names. Okay. The mean value theorem for integrals states this way. This enables you to be able to find the average value. So that's called f of c, f average, of f of x on AB. In other words, this will help you find the average y value, the average height on the graph in a given interval. From this, you can find corresponding x values, called the c values. Okay? So I put a picture there. Now here's the formula. So FC, or F average, equals 1 over B minus A of the integral from A to B of f of x dx. Okay, this just gives you an idea of how much stuff is going to be on this exam, right? I'm just trying to get everything in there. But here's just one more thing. No. Okay, now it says, so just so you know, this is what you're going to find, the height. So it'll take all of your, see the blue that was in the back? That would be the average height of all of the area under the graph. And that's f of c. And then c is the middle of that rectangle. Okay, so again, this would be the average height of function f of s. So when you think of mean value theorem, mean, the middle, the whatever, it actually makes more sense, the title is here, where mean value theorem with the derivatives is just finding other places that have the same slope as that average velocity or that mean velocity, right? So they're kind of separate entities with similar names. Now it says find the average value of the function f of x equals 1 plus x squared in the interval -1, 2. Okay, so f of c equals f, the average, is 1 over b minus a b f of x dx. Okay, so in our case here, it's going to be 1 over 2 minus -1, the integral of -1 to 2 1 plus x squared dx. That would be putting everything in. This is my a and that's my b. And this is f of x. Okay, so this is f of c. F of c, or the average of this area, or this graph, this function. We got our 1/3 out front, and I'm going to do the integral, which will be x plus 1/3 x cubed. And that's going from 2 to -1. Oh, that goes when you do the integral. Okay, now f of c would equal 1/3. Okay, so that's 2 plus 1/3 times 2 cubed minus -1 plus 1/3 times -1 cubed. Okay, now when you put that all in, f of c equals 2. Now remember, this f of c, this is a y value. I'm not finding c, that's f of c. So, and I've included a diagram to show you, here's the graph, 1 plus x squared between -1 and 2, and the average is 2. Now they may ask, what would be the c values that would give you that? Okay, so remember, f of c equals 2, right? And we know, so to find c values, you just go 2 equals 1 plus c squared. That's my original, right? So you give me the y, I have to go find the x, or in this case, to be more specific, the c value. Okay, so I'll minus 1 to both sides. I'll get 1 equals c squared, plus or minus root 1 equals c, so that's plus or minus 1 equals c. So you can see that I have this, my one c here and my other c there. So that average happens twice on this graph at 1 and -1s. So this happens twice. So these would be the c values at f of c. Okay, so again, what is this thing? This is the average height of that graph, of that function. And remember, that's the y. Height is always in y. Okay, and then yeah, but yeah, and the 1/3 will changes to actually find the height. Okay, so that's all that is, and then you can see that I have 2 questions here, and again, you'll be able to find that on the website if you're going to do those. I have no idea how that got tagged on there. So there's actually, oh, look at that. Okay, sometimes you actually print spacebar and there's that extra. Yes, think outside the box.